Hello everybody. This is the second topic of chapter 2. After introducing the impact of the construction sector on the environment, I think it is time to ask this critical question: how can we meet this challenge? Please note that you will be introduced with more details in the coming lectures, but in this video I'd like to address some recent and promising solutions to this given problem. The possible solutions and actions are not limited to the following options. However, they are among the most appropriate and widely adopted ones. Energy efficient designs in buildings can be achieved by having new constructions or renovating the existing buildings. It can be defined as buildings that are designed to provide a significant reduction of the energy need for heating and cooling. The equipment will be chosen independently to heat or cool the building. So the design concepts and use of advanced materials are key to lowering and operating energy. Designing a high-performance building envelope is possible through insulation, high-performing glazing and windows, air-sealed construction, and avoidance of thermal bridges. It is also possible to make passive arrangements to increase the energy performance of buildings by designing bioclimatic architecture, by adjusting the shape and orientation of the building, solar protections, and adding passive solar systems. If the buildings are equipped with HVAC systems, they can be upgraded to high-performance, controlled ventilation systems with mechanical insulation and heat recovery. Above-mentioned practices to reduce operating impacts are widespread. However, embodied carbon is another critical parameter that represents the energy and emissions from materials and construction activities, and it reaches almost 50% of the total energy consumption of the buildings during their lifetime. This figure shows that the reduction of carbon impacts during the building stage of a project is as important as the practices to reduce operating impacts. There are several steps that can provide significant upfront impacts in design and construction processes. For example, renovation and reuse projects have the potential to save up to 75% of the embodied carbon emissions compared to constructing a new building. Correct material selection is another key strategy to achieve it. Selecting low carbon concrete mixes, limiting carbon intensive materials, and choosing lower carbon alternatives and high recycled content materials are among the best strategies. Wasted materials like brick, metals, broken concrete, or wood should be reused whenever it is possible. Maximizing structural efficiency, waste minimization, and using fewer finishing materials are the other design strategies to reduce embodied carbon. As you have already learned, immense energy is required to manufacture building materials, supply construction sites, and to operate the building environment. As a response to this problem, one of the recent trends is to achieve net zero or carbon neutral buildings by focusing on curbing emissions across the whole building life cycle. It follows similar strategies, but it is required to have a holistic view that focuses on the whole building life cycle. In a carbon neutral building, emissions resulting from the materials, construction, and energy used in the buildings are balanced with on-site and off-site renewable energies and carbon storage. Another strategy is green buildings. A green building is a building that, in its design, construction, or operation, reduces or eliminates negative impacts and can create positive impacts on our climate and natural environment. The concept of green building aims for the previously mentioned targets, such as preserving precious natural resources and improving our quality of life. The details of green buildings will be covered in Chapter 8. Please note that. Green buildings has a number of features by being less resource intensive, making the least possible impact on the environment, and having improved quality, comfort and health of the occupants. Finally, I'd like to address another emerging economic trend, which is the adoption of circular economy principles in the construction sector. Simply, it aims to minimize or even eliminate, whenever it is possible, waste and pollution by improving efficiency and keeping products and materials in use in a circular manner. Circular economy strategies should be applied at every stage in the construction life cycle, from the design phase through building, operation, and eventually destruction and recycling stages.